Okay, so you need to add 1/4 to your x value of your vertex, so that's h. So when you add 1/4 to your -4, you should get -3 and 3/4, comma -1, still the same y value, and that's at this point here roughly. And for your directrix, you are going to subtract 1/4 from your x value of your vertex, so from h. So when you do that, you will get your x value of -4 and 1/4, and this is your equation for your directrix, and it is vertical because it is perpendicular to your axis of symmetry, and it's never going to touch your parabola. So when you do that, it's going to look like this. Okay? So those are all your points for your sideways parabola. So what does the focus in a parabola really represent? So all this really represents is the distance from your vertex. But it's not just that, because these, in your parabolas, these can be seen in real life all the time. So in a satellite dish, which, I mean, maybe you guys don't have satellite dishes anymore, but there is if you've ever seen one, there is a ball-shaped thing that's in the middle of your satellite dish, and so that is because when your rays come in, they will bounce off your parabola and meet at this focal point no matter where it hits your parabola. So it bounces off the side, and no matter where it hits, it's going to go straight towards your parabola. So that's something cool about your focal point or your focus, that your lines will come in and hit your parabola and go straight to your focus every time. So that's one cool quality of your parabola. And another thing, a more applicable one, I'm sure all you guys have used one of these, is a flashlight. So in a flashlight, it's a little bit rounded on the inside. So this is for satellite. Oop, can't spell. Satellite. Now this is for a flashlight. So you still have your parabola, you have your focal point, which in a flashlight, this is your light bulb, right? So they put the light bulb at the focal point, so then wherever your light rays, they will come off of the light bulb, and it'll hit this reflective mirror image, and it'll shoot straight out. So no matter where the light hits, it's going to shoot straight out. Okay, so that's just one cool characteristic of your focus, is that no matter where it hits, it's going to end up going straight out. So if it hits a parabola, it'll go straight to your focus. If it is coming from the focus, it can hit the parabola and it'll shoot out. And all of these lines here are parallel. Same with your satellite. All these lines here are parallel. So we're looking at one application example. So Sunfire is a glass parabola used to collect solar energy. The sun's rays are reflected from the mirrors toward two boilers located at the focus of the parabola. When heated, the boilers produce steam that powers an alternator to produce energy. Write an equation for the Sunfire's cross-section. So what we need to start out with, or what we need to think about, is when we're writing an equation, is this opening up or down? So since it's opening up, we know our x value is going to be squared, so we're going to have our equation of y equals a times x minus h squared plus k. So our equation is going to be in this form. And another thing that we could think about is it tells us that this boiler is our focus. Two boilers located at the focus here. So if this is our focus, we could make this point down here our vertex. So to make our lives easier, we can just make this point 0, 0. Okay? So if that's our point 0, 0, and something else we need to think about if we're thinking of our focus is our p-value. So we know our p-value is our distance from our focus to our vertex. And so in this case, our p-value is 10. Okay, and this helps us because we know our p is 1 over 4a, and this will help us find our a value in our equation. So if we have 10 equals 1 over 4a, to get our a by itself, we could do cross multiplying here. So we would get 40, 10a equals 1 when we cross multiply. To get our a by itself, we divide both sides by 40. So we would get a equals, those cancel, 1 over 40. Okay, so this is our a value. We can just plug this in. Oops. We can just plug this in into our equation where we see a. And something that we also know about our equation is our vertex, our 0, 0 here. So that shows us that our h and k is going to be 0, 0. So if we just plug everything in, we would get y equals 1 over 40 times x minus 0 squared plus 0. So when we simplify that, we get 140x squared. And this is our equation. So this is just one application to our parabolas. So we are done with parabolas. Sorry, this video is a little bit long, but hopefully it helps. And I will see you in class.